Welcome to Module 1 for solving quadratics. The next 3 modules will be more procedural, meaning like here's a problem we have to know how to do, here's an example, and then you'll get some practice with that. Module 1 is more about building background. Okay, we will be using graphs a little bit in Desmos to help us answer some questions, but this is the foundation for like why we need to have the content from modules 2, 2.5, and 3. So let's review what we already know about solving quadratics, or what we've already talked about. Okay, so in Algebra 2, we might have seen something like this, where we've gotten a quadratic and have it equal to 0. Now the focus that we've had so far is to use factoring to solve that, right? So we would find two linear factors. In this case, we would find two numbers that multiply to -3, and those same two numbers have to add to -2. Okay? So we would say, well, this is -3 and 1, -3 and 1, and we'd put our linear factors. And then we would use something called the zero product property, which sounds fancy, but basically just says if you have two things that multiply to equal 0, one of those numbers has to equal 0. Okay? So we would say our zeros from this function are x equals 3, because 3 minus 3 is 0, and x equals -1, because -1 plus 1 is 0. Okay? So factoring is great for solving some quadratic equations, right? But most quadratic equations are not going to be able to be solved using factoring, so we need some other ways. The best and easiest way for us is graphing, right? If you look to the right, there's a graph of x squared minus 2x minus 3, all right? And we've talked about this, but we know that the x-intercepts are what we call the zeros of this function. So those are the x values that we found using factoring. All right, so x equals -1 and x equals 3. So if we're given the option of how to solve any quadratic equation, the easiest way is going to be graphing. Okay? And so today we'll use Desmos for graphing. You can use the yellow calculator if you want, but I want to focus more on the content or the knowledge you need about it instead of like how to actually do the graphing. So we'll worry later about getting really good at using the yellow calculators to help us solve using graphing, but for now Desmos is going to make it easier on us. Okay, so let's go down and look at an equation like this. All right, so this is in disguise a quadratic equation, right? I could, if I want to do this the long way, like use box method on the left or distribute, and then somehow combine with the 14, right? But I can graph it just right now in this form. All right, so we want to know when these two sides are equal. So what I'm going to do is I'm just going to graph this left side. So I'm going to say y equals x plus 4 times x minus 7. And I'm going to graph the right side as y equals 14. Okay? So if we just graph both sides, we can easily find the solutions. All right. So let me go to Desmos. Now what you're going to do on your iPad is you'll go to Safari or Chrome and open up a new tab and go to just desmos.com. This is not student.desmos, but get to this page, and then right in the middle is the graphing calculator. Okay. Now we can put our equations on the left, so let me put in our two sides that we had there. We said we were going to put y equals the left side, so x plus 4 times x minus 7. And the other side was just 14, so we'll say y equals 14. Now I'm looking for when these two functions, this red parabola we see here, and then the blue line, which we can't see, when they are equal. So if I zoom out a little bit, I'll see there's my blue line, and there are two places where they are the same, and that's the places where they intersect. Right? So the x values of these intersection are our answers. Right? So -5.15 and 8.15. So using graphing, we got x equals -5.15 and x equals 8.15, and those are our two solutions. Okay? So maybe add that in your notes section on your paper. Solutions are the x values of the intersections. If you need to pause the video to get that down, please do so. Okay? But we're moving on to another way we can use graphing. Sometimes the question is asked a little differently, and it says find the roots or the zeros using graphing. Now, I mentioned zeros above, but roots and zeros really for us right now mean the same thing. All right? So, and this is another thing we should have in our notes. Roots / zeros, all right? These are the x values that make the function equal to 0. The x values that make the function equal to 0. Okay? And add on our graph, those are the x-intercepts. Right? So you'll see here for this function there are 2 x-intercepts at -1 and at 7. All right, so those would be our roots. In this case, we could also call them zeros or x-intercepts. Okay. So again, I'm going to add that note in there. These are the x-intercepts of the graph. So in the case where we have just a function that's given, right, where it's just like f of x or g of x, right, we can just graph that and see where it is equal to 0. We don't have to graph the both sides. Okay. Now, it's not always going to be whole numbers. Right? So if you look at one like g of x down here, right, I graph that, and you'll see here are the 2 x-intercepts, and we get these rounded decimals. Right? So if you were asked to find the roots of a function like this, right, that would be very difficult to do with factoring, pretty much impossible. Right? We have some other ways we're going to talk about, but graphing's the easiest, right? Just graph 3x squared plus 5x minus 2 and figure out those x-intercepts. Okay? So we could call this a root. It's also called a 0. Both of these points are roots or zeros. Now, the ones we've looked at so far, the parabolas, that's the U shape, or the quadratic functions, have 2 roots or zeros. Right? There's 2 places where it crosses the x-axis. There's another option where we have just 1, right? If we have a parabola that the vertex just touches the x-axis, there could be 1. There could also be one where it does not touch the x-axis. Right? If you're looking at h of x down here. Here's the x-axis, right here. And our function clearly comes down, hits the low point, and then increases after that, and it's never going to come and intercept with the x-axis. Okay? So what does this mean for us? Well, this means this has no real solutions. Whoops, can't spell solutions. All right, has no real solutions. There's no x value on that x-axis that's going to make this equation equal to 0. All right, but, here's the but, and this is why we learned about complex and imaginary numbers last week. All right, there are 2 complex solutions. So there's something called the fundamental theorem of algebra that basically says, among other things, all quadratic functions have have 2 solutions. All right, so whether they're real or complex, we're always going to have 2 solutions. So graphing is great, but when we come across a situation like this, we cannot use a graph to find these solutions. So we're going to need another way, which is where we will go to in Module 2.